All right, there we go. So I got it recording, so hopefully that'll work. All right, what's our next one? Sure, so this says, okay, choose the behavior, list the real zeros, that shouldn't be too bad. Find the Y-intercept, shouldn't be too bad. Graph it. Alright, let's check that explanation for sure. Yes, please. Yeah, for sure. Yeah, we need to learn. Okay. I think so. I mean, so finding the end behavior depends on the degree and the leading coefficient. So this one had 1, 2, 2 from the x squared, so 4. So the degree is 4, which is even. Leading coefficient is positive. So this is one where, again, you had to look at that and find the degree, even, odd, and then you had to look at those pictures again of those graphs that we took, those up and down ones. All right, so that's A. What's B? Behavior, so x 0, cosec x 0, positive 1. Does that make sense? Those are the roots. Those are the numbers that are make you zeros in there when you plug them in. That's not too bad. Multiplicity, there's 2 of them because you got x plus 1 squared, so 2 of those. -1 answers, multiplicity of 2. All right, what's that C part say? Intercepts. Plugging in all those numbers, 0, Y-intercept 0. Alright, that's not too bad. And then what's D? Graphing the function. Wow, so you're putting a point on on 0, on 1, and -1. Behavior at -1. This rises to the left. Okay, so go down a little bit. Okay, go up a little, or down a little bit more. All right, so we have to, once you find your spots where it crosses over the x-axis, then we have to make it match that graph, that picture, that graph that we have, hopefully. So go down a little bit more. And then click on the graphing icon. Okay, go down all the way. So down D, does it graph that for you? Go down. That's going to be interesting having to try to draw that graph. Alright, but I think we can do it, no problem. Got it. Alright, so we got negative. If we times all those x's, we would have x to the third. So negative x to the third, the degree is 3. So looking at those pictures there, a to the n is less than 0. The degree 3 is odd. Are you seeing which case that is? Are you looking at your charts? Because you got to know that for sure. A to the n is less than 0 for sure because it's going to be negative out there. And D, the degree is odd. So you guys got x to the third. So case 2. There you go. So what's that end behavior and what are your pull downs there? So that is rises to the left, falls to the right. Okay, so you're going to have to try to graph it to look like that. All right. Okay, where it crosses the x-axis,
I
don't know about that. All I know is all the zeros. All the zeros in this graph are -1, 1, and 3 because those are the numbers that give you 0 when you plug in those for x. So I would say 1, yep, for that one right there, 1, -1, and 3. And then now, I'm not sure how to find that one spot where it doesn't. So that would probably be looks like the far left spot. So that would be -1. The far left of all those numbers right there, if I would say. Let's see. All right, the Y-intercept. Right, there you go. The Y-intercept I would say is 0 because there's no other extra number there. And now we need to graph it. So we need to put a point on -1, but shoot, I don't know where that would be. Man, this is a tough one. We might have to just skip the explanation on this one, Sabri. I'm sorry. Because we gotta learn that this one has that 0 that doesn't touch the y-axis. So, alright. So we got that. We got degree 3. Like, go up a little bit. Hold on. That's okay. So we got the degrees 3. We got it odd. Coefficients negative. Rises to the left, falls to the right. So we're okay with that. Okay. So now going down. So we got those, -1, 1, and 3. We got those. That's where it crosses the x-axis. Alright, so what's that say? The behavior of the graph at x-intercept or 0 can be determined by the multiplicity of that 0. If C is a 0 of an odd, the graph crosses the x-axis at C. If C is a 0 even, graph touches but the axis at C. Holy moly, I'm going to take a picture of that right there. Is that your kitty? Wow. So C, what is C? All right, you go down. So Y-Intercept, when I plugged in zeros in there. Oh, I just figured it'd be. All right, so you got to actually plug in zeros and do the math. All right. So let's see, -1. Good. 1. All right, you can scroll down a little bit there. +1 to go up. All right. So up. Wow, that's so confusing. All right, can you go up a little bit? I want to see the very first point there they plotted. All right, so we got that. You know, it rises to the left. All right, so behavior at 1. That graph is below the x-axis as it approaches 1 from the left. All right. That's funny. All right, you go down a little bit. And it's got a Y-intercept. Wow, these are going to be challenging. All right. And then go down a little bit more to the answer. So where the graph touches but does not cross the x-axis. All right, -3. Where the graph touches but does not cross the x-axis. Oh, I see. Yeah, that would be like if I had just plain old x in there. Okay, that makes sense. Alrighty. I think I'm good to go. It's going to be a challenge, but we'll see. Got it. Is this it? Alright, so here we go, the degree. How many x's would you get if you times all that? Do you see? I see more than 3. So you got x, that x minus 1 foiled over there would give you x squared, and then you have those 2 other x's in front of it. So I get 4, I would get like x to the 4th. So x to the 4th means the degree is 4. That is more than 0. That is even. So what case would that be? So it looks like it's positive. See how there's no negative in front of all that mess? So that means the a to the n is more than 0 and it's even. So I see 3 for sure. Alright, so that tells you rises to the left, rises to the right. Alright, so looks like zeros were across the x-axis. Looks like you have -1, -2, and 1. And then where it touches, but I would say none right there. So that means if you go back to that equation and you plug in a 0 where all those x's used to be, so you're going to get 0 plus 1 in parentheses times 0 plus 2 in parentheses times 0 minus 1 squared. Here, I'm going to take a picture of that. So that picture eventually comes and shows the math you're going to get when you plug in zeros into the x. Heard that. All right, I'm waiting. How many do you have? How many do you have? Ooh, that's a lot of tests. Yeah. Nice. All right. While you're doing that, I went to Desmos. I'm typing that in. I want to see what that looks like. This graph. It'll tell me. And that's x plus 2 squared. Oops. And then x minus 1. I get 2 is the Y-intercept for sure. Yep. Alright, I'm going to send you a picture. I think this is the equation. I'm going to send you this. So I went to Desmos and I typed it in. And I could see exactly what that graph is going to look like. Let me send another picture. Here comes that last one, hopefully. Man, that's going slow. Maybe mine. And then I think I have to change that one answer that says none. I see one spot where it's touching the x-axis, but not crossing that. And that's at 1, positive 1. Just positive 1 right there. And then, come on, pictures. I got 2 coming there. So it looks like graph, it touches at -1, at -2. That looks all good. I got another picture coming too. Alright, so now we're ready to graph it. So you got a dot on -1, you got a dot on -2. Nope, these are all on the x-axis. So I want to erase that one. So -1 right there, perfect. That's exactly, yep. And then select how that's going to be, and that's going to be that far left one if I'm looking at the picture of that graph. Yep. And then you got a dot on -2. And that one's going to be that middle one right there. There you go. And then you have the Y-intercept, right? So +2 on the y-axis. Oh, gotta get, that's not right. All right, that, yeah, you can do that one. That's fine. Let's do the Y-intercept first, though. Go up to 2 right there. Perfect. Let's do that one first. And then the other one is +1 right there. And then that's going to be that far dip to the right. Yep, there you go. And then go back to that Y-intercept one. Because you have to, I would erase that one then. Let's do that one again. It's not letting you do that, huh? No? So, what's that icon to the right of the eraser there? What's that? Huh. Well, maybe because it's a Y-intercept point, it's special or something. You need to plot a Y-intercept. How do we plot a Y? What's that? What's the thing beneath that dot? What's that icon? What's that? So click that Y-intercept button and 0 to plot point. Wait, that's not right. Can you, that's so confused. Can you undo that little graph thing? This is what's not there. The graph that we just did. Oh my goodness. I know all the other answers are good. We just got to try to graph that again. I mean, just put the 3 points on, I think it was, what was it? It was -2. Just, there you go. Just try that one, I guess. And then that was that, nope, that right one. There you go. And then, there you go. And that's going up. Perfect. And then hit that. Try to do the. Okay, there you go. That's 1, 0. Perfect. And that's that one. Good. There it is. Worked. Yay. Do you see how that matched the picture on Desmos? So if I was you, my advice is you could easily do the Desmos app on your phone, and you could type in that exact equation just with all the parentheses exactly, and get that graph and be able to look at that graph and see what it should look like. Does that kind of make sense? Have you ever used Desmos? Okay, I'm telling you, because without looking at that picture, I think graphing that one would have been twice as hard. B, what's B? So -1, -2, 1. Oh, that one right there. Just change. That should just be 1. Yeah, there we go. What did it say? Does it have the answer? So -1, -2. Got the graph. So we missed just the B part, right? Go up to B. What's it say for B? Oh, here it is. So we had -1, -2. So we did have those answers there. We did have that. Oh, you did? Oh, yeah. Okay. Go up a little bit. So -1, -2, but that multiplicity one. Oh, yeah, because we listed that 1 as one of the places where it's crossing the x-axis, but it's not. Do you see that? So if we had that +1 out of there, we would have got that one right. All right. Live and learn, right? So let's just go to the next one, because we'll get it. And then I'm going to open up Desmos on my phone. Okay, I just went to the App Store, just downloaded it. I'm going to type in y equals negative in parentheses x plus 2. Close that parenthesis, that's going to be squared. Open up another parenthesis. I'm going to take a screenshot of this and send it to you. Left parenthesis x minus 1. Close that parenthesis. So this picture I'm sending you, hopefully it'll come, is the exact picture that I use when I use my Desmos app on my phone instantly. I don't know, do you see that? So that might help a little bit on these. So looking at this problem, it's negative, see that negative out front? So that means a to the n is less than 0. I have x squared because of that FOIL plus one more x, so that's x to the third. So this one is a to the n less than 0, and it is odd. So if you look at those other cases, those pictures that we took, that it matches case number 2, right? Yep, rises to the left and falls to the right. And I can see on my Desmos picture does that exactly. Alright, so now where it crosses the x-axis, so when we have one of those places, and that's the positive 1. So positive 1 is going to be that one right there. And that's because I'm looking at that equation, positive 1 is the opposite of that negative 1. I don't put the negative 2 as part of that answer because that's where it opens up and doesn't cross the x-axis. So the second answer is going to be negative 2. Yep. And then, are you seeing where I got those two numbers? Do you have this on your Desmos? You do? Did you type it in, or? Okay, because I'm looking at that graph, so I can clearly see, right there, crosses the x-axis at 1. It doesn't. It touches the x-axis, but doesn't cross it at negative 2. I mean, it helps a lot for sure. All right, now the Y-intercept, it looks like it is 4 on this one. And then I got that 4 by just looking at my Desmos graph, but I could have got that 4 by plugging in 0 into that 0 plus 2 and 0 into that x minus 1. And that work would have gave me a 4, 2. I'll try to show you that. So that gives me negative 2 squared times negative 1, which is negative 4 times negative 1. That gives me positive 4. Just in case you don't have Desmos and you got to plug in 0 for x's on that one to get that 4. Alright, now we need to graph it. So graphing it looks like we got a point on negative 2. Well, now I'm looking at the Desmos graph pictures to help us graph it for sure. And then there you go, perfect. And then I would do the Y-intercept. So I'd use that. Remember I used that grid thing? And then the other one is at 1, just a point on 1. There you go. Perfect. Yep, that's what I get. Ooh, what's that? You don't need that last one there, that 6. I would get rid of that. Oh, it's just you moving it. Alright, let's plot it, see what it looks like. There it is. I think you should get that problem correct. Yes, there's so many parts. All right. Yeah, those problems weren't that bad, and I don't even remember doing those with you. Those must have been, you must have did that math before I even started helping you. I mean, those are just like simple FOIL problems and some radicals. Nothing compared to some of this math. But oh well, hopefully I'll get 100% on that. That's cool. Either way, 93, that's a good grade. It was, and I took that equation and typed that exact fraction in, and it worked perfect. So that answer I know was right. It was just a notation thing, the way Desmos was acting, or not Desmos, the Alex was acting weird. All right. Cool. I'm typing this into. The good thing about Desmos, you could type it in exactly, hitting that squared button, a squared, hitting those parentheses, x, got a minus there, use the minus button, 1, close that parenthesis. Oops. Ooh, it looks pretty complex. So here, I'm going to send you a picture of what I got. See the matches first. So falls to the left and rises to the right. Yep, that's what I got too. Good job. And then where the graph crosses the x-axis, looks like the only place it crosses is at +1. Looks like there's 2 of them, right? So 0 and -2, or type in -2 first. -2 and 0. The Y-intercept looks like it's 0. And then now let's plot it. So we got a point on -2. And that looks like that's that 1/3 one to the right. There you go. Got a point on, there you go. That looks like that. Perfect. And then a point on 1. It's +1. There you go. Perfect. And that is opening. There you go. That's what I get. That's it. That's the way it looks like on mine. That looks perfect. Alright, try this one, lady. Desmos at first, for sure. And then when you were taking that test, was it easy for you to use your phone and not have it see you, or That's funny. Of course you got something like that. No. Of course. That's comical almost. That's funny. Yeah, mine looks like a W that has, it touches at -2, it touches at 1, but it doesn't cross. It looks like my Y-Intercept is 4. Looks like it's rising left, rising right. Crosses x-axis, none. There's no spots for crosses the x-axis. Oh, not that one. That top one's none. And then that's definitely got 2 spots, but -2 and 1. Y-Intercept looks like 4. Now graphing it. And sure is easier graphing looking at the Desmos picture. So that's the Y-Intercept. Do that as the Y-Intercept, right? So I wouldn't do it as a dot. Remember how you had to do the Y-Intercept using that little grid button? Hopefully, there you go. That's it. See if that works. See, how come it didn't take that as a Y-Intercept? I don't know why it did that. Yes, that's it. What did you do right there? Maybe you had an extra point there or something. Yes. Alright, that looks good. Yay, yay. Alright, let me grab a cord. My computer's gonna die here. Got your little workout thing ready. You ready? Alright, I'm back. You remember these? Are you there? These are tough ones. Do you remember? Yeah, let's look at the. Oh. Let's definitely look at the explanation on this one here. Hello? Yeah, I don't. Yeah. Oh, you. Okay. So the equation x plus z equals 120, and then a, and you solve for z. Okay, I remember doing those a little bit. 2x plus z. And then you solve, and then you plug in one into the other. I remember. Yeah. So z equals. And you plug that into that. Okay, I remember that. And then maximum. Standard form, quadratic, maximum at the vertex. All right, go down a little bit. So we did negative b over 2a. We got 30. Okay, that makes sense. I remember doing that. Then go down a little bit. And then using that to plug in is the area. All right. I think these are doable. If you got one right, good job. That's a lot of math. Yes, you did. Okay, so we got x2 squares. So 16. Alright, so this is a weird one where you have one square that's x by x, and then the other square is 16 minus x, because that's what's going to be remaining of that piece left. So I got one equation's x squared. Oh wow, because this one's a little bit different. X squared plus 16 minus x squared. So let me send you a picture of this. I think this is what you do for this one. This is a little bit different. Oops. That's coming. So the x by x is the original, but if you have that 16 centimeter piece, whatever's left of it, 16 minus x, that's going to be for the second shape. That makes sense. So if I FOIL that last one, 16 minus x, I'm going to FOIL that. So 16 times 16 gives me x squared plus 256 minus 16 times 2, 32x plus x squared. I get this function is 2x squared minus 32x. Pretty lengthy one, but this is what I get right here. Because the x squared, pretty straightforward, but the 16 minus x piece that when I fold it was a little bit harder. 16 minus x times another 16 minus x. So when I combine them together, I get 2x squared minus 32x plus 256. And then go down a little bit. So minimum, I guess, would be the vertex negative b over 2a, where b is 32, so negative 32 over 2 times 2, I get is 32 over 4, which I get is 8. That's what I'm getting. I'll show you. I thought that one. So 8 looks like the x-coordinate of the vertex, the very bottommost part of this. So that picture's coming. And then if I take that function and plug in 8, I get 2 times 8 squared, 32 times 8. I get 128 when I took that vertex 8 and I plugged it in to the equation. So for that B1, that's definitely going to be 8. And then C, I think, is 128, I believe. I hope. What's it say? Alright, we might have to check the explanation on this one. That's okay, they're easy to get back though. 2 in a row. Oh, I did that completely wrong. So 4, let me take a picture of that. Okay, you go down a little bit. And then right there. Okay, I see. And then going down to B, looks like they did the vertex, and then they plug that in. Alright, so we got these, knock this section out. Yeah, but we got that for B. Remember C, we got like 128, so we weren't even close. But we'll get these next ones. No, I'm okay on that. Okay, so this one's a little easier. So it's x plus that unknown z. So x plus the unknown, I'm going to call it y, equals 480. I know that area is xy. I know that if I take that equation and solve for y, I'm looking at y equals negative 2x plus 480. And if I take that and plug that into the other one's y, I get x, and I'll show you a picture of this. I got distribute. So I'm going to distribute, and that gives me negative 2x squared. So this is the math that I did. It should be coming. So 2 of those x's give me 2x plus y. To solve that, take away 2x on both sides, give me y equals negative 2x plus 480. When I substitute that into the y for the second equation representing area and distribute that x, give me negative 2x squared plus 480x. Yes. Got video, you got a picture of that on your phone, and then hopefully this video I'll be able to send to you. We'll explain that hopefully. Alright, so now we got to use the formula negative b over 2a. So for that function right there, do you know what b and a are? Can you recognize what numbers those are? Because if what number is b and what number is a? Yes. Yep. So if I plug that into negative b over 2a, I'm looking at negative 480 divided by 2 times negative 2. So I'm looking at negative 480 divided by 4. Gives me 120. I get. Picture that for you. That's for B. And now if I take that 120 and plug it into the function, it gives me negative 2 times 120 squared times plus 480 times 120. My calculator, negative 2 times 120 squared plus 480 times 120. Well, I get 22800. Let me double check that. Yeah, 28800. That's what I get. I'm hoping, man, hoping. Hallelujah. It's tough. All right. Okay, so this one, the equations, because they're using all 4 sides of this rectangle, you got one equation for perimeter, one equation for area. So for the perimeter, I'm going to write it as 2x plus 2y equals 240. The second equation, area, I'm going to write that as x times y. So those are going to be my 2 base equations that I'm solving. Let me send you a picture of that. And that's coming right there. You see that? So the top one is perimeter. 2 of the side pieces plus 2 of the top and bottom pieces equals 240. And then the area of that is x times y. So I'm going to take that top equation, I'm going to solve that for y. I'm going to take away 2x. That gives me 2y equals negative 2x plus 240. I'm going to divide everything by 2, and that gives me y equals negative x plus 120. I'm going to take negative x plus 120 and plug it into y, and that gives me x times negative x plus 120. I distribute, I get so that's pretty lengthy there, but that picture coming at you, hopefully seen right there. So that top part is me solving that equation for y, and then I had to plug that into the other equations y. I distributed that to get that answer right there, negative x squared plus 120x. Alright, and then negative b over 2a would be negative 120 over 2 times negative 1, so it looks like 60 on that one. And then if I plug in 60 into that equation, negative 60 plus 120 times 60, I get positive 60, yep. 20 times 60. I get 3,600. Here's a picture.
Do you have to sign up for it? Or?
Yeah, it says sign up now.
Oh, yeah, let's do that.
The Office of Admissions Applications.
Alright, so that picture coming at you shows the work where I got b, negative b over 2a, where I got that 60. And then I took that 60 and plugged it into x squared and got 3,600 on that one. Yay. Then we do one more. Call it. Whoa. I'd have to look at the explanation. I have no idea. Take a look at it. So 8 length is 8, side is 4, 8 minus 3 of those x's, oh my goodness, let me take a picture of that. Okay, you go down a little bit. Take by Hold on a second there. Let me take a picture of that. God, this is complicated. Okay. You go down. And then that volume right there. And then you had to graph it. What? And then you had to do that extrema stuff. Oh my god. This is the most intense problem. I guarantee you the next problem they're going to shoot you is going to be not even the same as that. But we'll have to look at that explanation too. Alright, so what's the answer on this one? Wow. Might go up a little bit. All right. Good luck. God. Okay, so that has two of those pieces being taken off. So that top part would be 3 minus 2x divided by 2. The other one would be 2 minus 2x. And then the equation is x. So this is what I get. This is a picture I'm sending you. I'm hoping. Oh man, so this is God, man. I don't know, because this is a different looking box than that first one. I'm not sure if I divide by 2, but I would type that equation in that I sent to you. Okay, so how about type in y equals, let's go 3 minus 2x. And that's got to be in parentheses if you could. And then the other, that's the top part. And then the other one, you got to try to type in parentheses 2 minus 2x. And then in the other parenthesis, you just plain old x and hit graph it. Alright, so it looks like between hit extrema, and you want to go between 0 and 1. So 0 and 1, and hit find extrema. So it looks like, yeah, 0.3, is that rounded? What is it having you round to, do you remember? Alright, so 0.39. And it was 1.06. Cross your fingers. Try that. Did we get right? Oh, sweet. Those are money. Easy. Knock them out.
Pretty.
What? Of course, this is different than the other one. I had no idea. So it looks like perimeter is 19. So if the perimeter is 19, that means that top piece, 19 divided by 4, that top piece is 4.75 long. So it looks like I think it's going to be it's going to be 4.57 minus 4x, I think, in one parenthesis. Other one's going to be 4.57, and I think the last one's going to be x. I'll send you a picture. I don't know. I'm thinking I'm going to get this one wrong because it's different. I'll have to see what they say. But in one parenthesis, you're going to have 4.57 minus 4x. And in the other parenthesis, 4.57. And then that one, x. Graph that. See if it gives you anything. Alright, so looks like between 0 and 2. How about? Try that. Looks like 0.57. And that one's 5.97. I know, probably gonna miss this one, but whatever. Alright, yeah, you're gonna have to see, this is a different one, so we'll have to learn. Alright, what's it say? So go down. Oh, go to the explanation, let's see. Yeah, I have no idea. Yeah, I have no idea what it's saying. Okay, so let's see. Go down. Alright, stop right there. h, so 8x plus 2 of those h's equals 19. Solve that for h, volume x times that. Alright, so go down. Hold on, let me take a picture of that right there. Alright, I got that one down pretty good, and we should be able to get a problem just like that. And then I got the other one down too. No, I think we're all good with that. Let's just take it away. Let's see. Okay, so this is like the very first one. We got it, no problem. So this one is 9. So we need to get that graphing thing going. Alright, 1, you're going to get 9 minus 3x. And but that needs to be divided by 2 though, that whole thing. I don't know how you would do that. Maybe you gotta hit that fraction thing before you type anything in there. So parentheses, I don't know. Alright, well, if I took not, there it is. So 9 minus 3x, and that's over 2. Close that parenthesis. Alright, the other one is 4 minus 2x. And then the last one's plain old x. There you go. And then graph that. Okay, looks like our extrema is between 0 and 1. So go to that extrema and 0 and 1. Alright, looks like 0.78 and 6.34. Alright, we got the tools. Alright, we did one of these already. So this is just plain old 6 minus 2x in parentheses. And then the other one is 3 minus 2x. And the last one is x. Graph that. Looks like between 0 and 1 again. There you go. Good job. That's what I get. Probably that square one. Yep, that one. I knew it. I got a picture. So let me look. Glad I took a picture of that one. That sneaky one. Alright, so this is, whoops. So this is 8x plus 2h equals 17. Solve that for h is 17 minus 8x divided by 2 is 8.5 minus 4x times x times 8.5 minus 4x. Alright, I'm going to send you a picture of what you're going to type in for that one. A little bit blurry. But you're going to type in parentheses x and then another x. So you have two of those x's. And then another one. And then your last one's going to be 8.5 minus 4x. There you go. Graph that. Looks like between 1 and 2, right? So 1 point. There you go. There it is. Yay, hallelujah. Alright, I'm gonna have to probably upload this video to YouTube, and then I'll try to send you like a link to it so you'll be able to watch it if you want. Be like a resource for you. Okay. Okay. Sounds good. All right, for sure. Try to get that done, and yeah, good luck. All right, I'm gonna Venmo you, okay? All right, lady. Good luck. Bye.